Okay, now we're going to do section 4. That is change detection with another flavor of Bayesian updating of land cover called bulk D. And what that refers to is bulk with not using classifications, but using individual values like normalized burn ratio or NDVI. And what we do is we establish an expectation that you see here. Well, first we build and fit the harmonic curve. We then figure out how different a value is from that. We then assess whether it's quite different, and then we make a map. And so what we'll do now is go to code checkpoint F48C. 48C is down here. And if you go to 48C, that goes to this spot. All right. And I'll see if I can go about reproducing that here. So this is another 6,000 line program that Mary wrote. And it's a very, very big job that she just finished a month ago as of this time, right around this time in March. And I'll hit run. And what this interface brings up is another one that has a Bayesian flavor to it, but where we don't work with classifications. Instead, we work with individual values. And so let's go and see what the values are. So here we can take in information from Landsat 8, Landsat 9, and Sentinel-2. And then what I'm going to do is grab these coordinates. I'll triple click on that, get these coordinates, starts with 61, and go back to here and triple click on that part, hit backspace, hit that there. That's for the coordinates. Here's Landsat 8, 9, and Sentinel-2. The text also says set this to 2020. See if I can do that. Yeah, let's go back and take a look. We go back here. So 2020, day 1 to 365. Do that. 2020. Then day 1 to 365, 70. And then 2021. So again, with 1 to 365 and 70. So that's what these are. Then we have the day step size, and that's for as we are building the expectation, we make bins and we calculate the average value in a bin of days. So we collect up 10 days of NBR values, normalized burn ratio values for Landsat 8 and Landsat 9 and Sentinel-2. We figure out the average value, and then we ask whether that is changed from last year or not. And so that's the idea. I'm going to grab finally this location, which I think is actually the same location as before. So we'll go here. The instructions say to set this to NBR images. If you make an account for NICFI, which is the high resolution planet data, you would be able to click and use this. Here's the 10, the NBR, and I'm going to say bulk. And that should zoom in to this spot here in the middle of Brazil. Now, I think if I remember right, yeah. So there it is there. We mentioned putting this in. Go to that spot. That moves us, I think, maybe over very slightly. And it brings us to another one of these square fields. When we look at this field, we can see that last year, I'm going to call this last year and this year, even though it was 2020 and 2021. Last year, this NBR value was very dark. That means when we look around at what that means for NBR, it already was probably changed very recently. And so it was already changed. Then in 2021, this year, this is what we see. So this number went up maybe a little. In some of the places it went up a bunch, and those are shown here in blue. Over here, you can see I moved the camera, or I moved the pan over just a little bit. This is an area that appeared to be forest before and maybe is not forest. I'm going to move out and show you a bigger perspective of what we see. Here, if we zoom out further, you can see that the normalized burn ratio image of last year, that's where we were. We'll see if we can go find a place that's interesting. So let's look here, this very bright red. So this bright red is being highlighted because Bulk says, I got a lot of numbers that were high before and now they're low. I'll try to move all the way across real straight. So this area here underneath my my cursor here has been changed over time. So this is a late period image from the first year and a late period image from the second year. It's not an average, but you could think of it as a representative image or an average image. If we then change to the chart inspector, we could look to see what values it saw here for bulk D. So I've got the chart inspector. I'm going to click on one of these red pixels, and you can do that too. Tells us the latitude and longitude. And here is what it says. It says last year, using these three sensors, you remember Landsat 8, Landsat 9, and Sentinel-2. For this particular year, Landsat 9 didn't exist yet, but so anyway, it's Landsat 8 and Sentinel-2. But more generally, taking these images, I get the same number every day. There's a little bit of harmonic curve. It looks a very, very slight curve here has been fit. But when we look at the target year, this year, the target year versus that fit, that same blue line, something happens a lot right around day 161 or 191, if I'm, 181. And then somewhere around in there, that value changes a lot. Now, if you think about that confidence that we have when we talk like before about trying to make an estimate through time of how confident you are that something has changed. We don't necessarily need to wait to the end of the year to say that we think that this pixel has changed. Maybe on this day or on this day, we would say, I think it's pretty likely the pixel has changed. It had a very small variability last year, and it has changed a lot relative to that variability. So when I get this number, that's some pretty strong evidence. When I get this number that's even lower, that's even more strong evidence that this number, the NBR value, has changed a lot. And if the NBR value is meaningful, as it is here for tracking deforestation or degradation, we think, then it is really different. And it's worth noting. Same kind of thing if we click over in this red area. This red area, which I can barely even see here on this, but I can see it once I'm alerted to it. Here, it says it was called this, and then very soon after, even on day 21, it got a little evidence, but maybe within the pocket of expectation, not too crazy compared to last year for this one, but a little bit of evidence that it was lower, but not extreme evidence that it was lower. Then on this day, we got another value even lower than the previous value. And then here, we got another number. Now here, our number is not radically lower than what we expect, but it's lower than what we expect. And so we have a very quiet signal compared to this very loud number down at the bottom. We have a very subtle signal, but saying again and again and again, NBR is different. NBR is lower, NBR is lower, NBR is lower. It's not a lot lower. It's maybe only 10 or 15% lower, but it's a consistent signal. It's different than if the value were jumping up and down by the same amount. You would say, well, maybe it's just an unusual year. And so that is how that works for these very bright red pixels. If we look at this lighter red pixel, I don't know why, it's less certain. That's what we'll see. I'm not sure why. I've never looked in this place before. So here we have a pretty similar curve to what we had when we clicked on these other nearby areas. It's around 0.5, maybe a little higher, with a little bit of a hump around day 200. And that's what we see the whole time. But then at the very end of the year, we see a big drop off, but then a bit of a recovery, and yet still evidence that something has changed. And it happened late. So we have just a few pieces of evidence that this NBR number has changed. It's just a little bit of evidence that the NBR number has changed. And so we leave its color, or the math of bulk leaves its color to be pretty level between red and green, probably, because there's no probability from what we see that the value has gone up. So probably this is a split between the red and the green color, leaning a little more toward red. That's what we get here. Now over here, if I click on this blue pixel, that's one that had much more periodicity in the previous. Most likely this is already converted to agriculture and used in some way. And then when we look to see in the target year, for whatever reason, this number stayed high throughout the whole rest of the year. Now, maybe that is because this has been changed to fallow. Maybe this has been abandoned land. It's hard to tell by just comparing these two images against each other. These are just two images out of a large set. Here you can see there's probably 30 or 40 images, I guess, thinking of all the different bins that have been filled. And yet this area has changed in a way that this area very near to it, I'm going to try to click there, the green pixel just a little bit to the south, pixel that's green, this one went, up and down and a bit of up. Here on the same day, there's still noise. In the same period, there's still noise. And the argument of bulk, the argument that we would make with this program is that if we are interested in looking for recovery, we should look in the blue areas, the areas that have some evidence of recovery. If we're looking for late changes or minor changes, we should look for colors that look like this. And if we're looking for persistent changes or very large changes, we should look for this bright red. And that is the idea of what BulkD does. You can run this across a very large area. One of my students is running it over all of Canada. And what she has seen is that the algorithm works very, very well for harvest and also for fire. It's really, really working very, very well. So we're pretty excited. So that's the idea of this section. I think that's about the last part. If you zoom out, you should be able to reproduce this image here. And here you can see some representative pixels that I picked. But again, there's a million pixels on the screen. So you can reproduce that by typing in this longitude and latitude value if you want to see these exact curves, or ones close to it. This one has 5 decimal points, but Earth Engine will only let you move to somewhere with 2 decimal points of resolution and granularity. And so that's what we see as an example of an increase. Now, the one that we looked at looked different than this, and yet it also was colored blue. Here's an example of a green pixel, one that isn't changed the way that we've seen it. And so that the end of section 4. And next, we'll do the last section talking about bulk with dynamic world.